Are you ready?
Yeah.
Hello, my name is Joseph.
My name is Kimya.
My name is Merielyn.
And together we are the Data Dreamers, seeking to use predictive modeling to track future illegal palm oil plantation in Kalimantan. Now, why is this important in the first place? Well, the Indonesian government has an active interest in actually tracking down all of the illegal palm oil plantations. There was a 2019 government investigation done by the Indonesian government that found out that 1/5 of all the plantations all across Indonesia have been identified as illegal. And from 2014 to 2019, Kalimantan has continued expanding their land usage for the palm oil industry. And we suspect that there's going to be future usage of that land, future expansion. So regular oversight has been, of course, more prevalent and more prominent uh, for uh, for this year. And so we are representatives of the company Hara. So I'll pass it over to Merielyn to introduce who we're all about.
Okay, so this company that we represent, Hara, is a blockchain-based data exchange company for the agricultural sector in Indonesia. It works with data providers, qualifiers, buyers, and value-added services. We have been collecting data on farmland and other agricultural identifiers in Indonesia for the past 16 years. Hara has also launched a pilot project in 41 villages in eastern Indonesia to collect data on market, geospatial, and weather information.
We propose a two-part solution to tracking future illegal palm oil plantation locations. First, we can use HAR's pre-existing data and technology to create a standard interactive map of plantations in Kalimantan. Second, we can use machine learning to identify where new plantations are likely to arise. Therefore, we can help the government enforce regulatory compliance by allowing them to effectively allocate resources where needed to prevent future illegal plantations. In terms of data sets available, Hara has over 3 million points of data available and has been collecting data for upward of 16 years. We have a range of categories from farmer-related data to ecological data, and a few examples of specific subcategories are farm addresses, soil data, and weather/temperature data. So this data could serve part one of our proposal, the geospatial data visualization, because it would help fill the gap in prior efforts. For example, Indonesia's One Map initiative has yet to be successful because despite attempting to create one standard accessible map, they faced the obstacle of a lack of available and reliable validated data. Our proposed solution is to create a publicly available interactive geospatial map. Then it can identify two key points. First, the location of legal plantations, and second, the location of prior identified illegal plantations and where illegal plantations have been found in the past. We propose that HAR creates this publicly available map because we have the parent organization for HARA has partnered with the World Bank and has access to reliable data that can be streamlined to help various government, environmental, and humanitarian organizations. And later we'll cover why it's important for this to be publicly available and the advantages of that.
Yeah, and so for the predictive modeling part, where we're trying to detect where there are potential plantation areas which could be illegal. So obviously there's one gap in that the government lacks the detection of all potential plantation locations. And according to this the literature, the state-of-the-art research paper that I've read, there's also another, so they've also tried, the researchers there tried also predictive modeling, but they said a couple of deficiencies that they were lacking in was they had limited coverage of the Kalimantan area, and also they didn't have any form of validated data. But we as HARA, our fundamental source of data is validated, and we are continuing to expand our coverage of data collection. And so we as HARA seek to fill in the gaps of those deficiencies. And for the modeling parts, we plan on using variables, parameters such as the distance from the nearest police station, soil quality, and elevation as example variables that can be used to train a model that is able to predict where the most promising locations of palm oil plantation, because the logic is that essentially illegal palm plantations would want to be kind of far away from the nearest police station and have a ripening area, and natural soil conditions and elevation that can do that. There may be other variables that we may have to consider, and so to figure out those variables, we can use clustering methods. And then using this improved data, we may be able to improve the current regression model that was proposed in that research paper.
Next, we'll talk about who our target client is and why will our implementation be effective. Part 1 of our project will be geospatial data visualization. It'll be an open data source, and it can provide a comprehensive overview of the currently available data to both the government and the general public. It can help them to better understand the extent of the current regulatory issues of the palm oil industry. An incentive for the government to adopt our data would be that it would encourage farmers to self-volunteer data, because farmers would want to be clearly identified, like farmers and individual small-scale farms will be willing to be clearly identified as legal and to distinguish themselves from illegal ones. Because this public availability will also be a potential marketing strategy for the legal farms, it can potentially disencourage new illegal plantations from entering the market. And part 2 of our project will be predictive AI modeling. This will only be available to the government and law enforcement agencies because we do not want our data to be in the wrong hands. It will more effectively identify potential illegal palm oil plantations and help them better enforce legal practices. And here are our short-term and long-term progress goals. In the short run, which we define as the first year within our project launch, we would be using the methodologies that our company already has in place. We will also be expanding data collection, and we will also add specific criteria to determine the prerequisites for a profitable plantation. For example, we'll be focusing specifically on weather or land quality or proximity to water source. After we have sufficient data, we will be creating geospatial data visualization. In the long run, we will use that geospatial data visualization we created and generate the predictive AI modeling. As we expand our database, we will also be improve the precision of our model, and we will also get a better idea of some potential identifiers to distinguish legal plantations from the illegal ones. One idea that we have currently would be the proximity of the plantations from police departments. And here are some evaluation metrics that we use to measure the success of our project. Basically, we'll be conducting statistical analysis on trends in data. We will be comparing these identifiers before and after our project launch. We will be looking at whether there's an increasing rate of the expansion of our data collection. We'll also be looking at whether there's a higher rate of the detection of the number of illegal plantations per year. And we can also look at whether the cost has been significantly reducing that's spent by the government on identifying or regulating illegal activities.
In terms of the benefits, there are both short and long-term advantages. The short term, or as we define the first year, there are both financial and environmental benefits. We already, as HARA, have the data, the technology, and the methodologies already available to execute part 1 of this research proposal. Therefore, the primary cost is the cost of labor needed to create the standard data visualization. In terms of actual numbers, this could range anywhere from $50,000 to $200,000. Really varies depending on how much labor costs and how long the project in terms of hours takes. The environmental benefits of this is offering a more streamlined set of data available to humanitarian, government, and environmental organizations to better focus on what areas need priority attention. In terms of long-term scalability, the long-term financial benefits significantly outweigh the short-term cost of simply paying for labor to create part 1. Because by ensuring that we reduce illegal plantations in the long run, we can help the government ensure that profits from the palm oil industry are contributing to the GDP and helping build infrastructure such as healthcare, education in the country. Considering how the palm oil industry is a multi-billion-dollar industry, it's important that the government is reaping the benefits to give back to the country. The environmental benefits of...
Excuse me, we're out of time. If you could wrap up quickly. Sorry.
Yeah, sure. The environmental benefits include reducing deforestation, preserving indigenous lands, and preserving biodiversity.
So by geospatial data visualization and predictive AI modeling, we aspire to help the government and the general public be better informed about the future of the palm oil industry in Kalimantan, and together we will better regulatory oversight of the Kalimantan palm oil industry.
And those are our sources.
Thank you all very much. Excellent presentation. I'm going to go ahead and I'll start the questioning. My question is this. You developed this predictive model of where you think you might see illegal plantations. What do you do with that? Like, how does that impact? What's the next step after that predictive model?
So our goal in creating a predictive model that can locate which areas of Kalimantan and other areas in Indonesia potentially would be suitable for new plantations can help the government allocate resources such as human labor to go monitor those areas and ensure that any activity taking place or people starting a new plantation have the proper permits, documentation required to start that plantation, whereas the government currently may be trying to guess and spread their resources across the island. It's much more effective financially to reduce that human labor by relying on machine learning to help identify which areas need attention.
Okay. So if a new plantation showed up in one of these areas, you might say, oh, we better go investigate if that's legal or illegal.
Right. Our thought process is that preventative measures will outweigh current systems.
Excellent. Oh, so do the other judges have a question? Feel free to unmute yourself and I'll use that. Laura, you have a question?
Sure, yes, and that was actually one of mine that you just asked, Rob, so thanks. So I was just wondering, because you mentioned one map, and obviously that's been a huge investment by bilateral donors and the Indonesian government. So it wasn't clear to me, would this publicly available data visualization incorporate into one map? Would it be only standalone? Could it do both? And also, what is the incentive for you as a private company to be providing a publicly available data visualization and maintaining it over time? Who is the client exactly who is going to pay for this?
I can also take this question, but if one of you wants to take turn.
Our client usually would be the government, first of all. They would want to like spend some money on buying our especially I think we make most of the profit out of the predictive model because the government would want to be able to more effectively identify the potential locations for illegal plantations. But because the previous open source visualization helps in terms of both data expansion and just to get a comprehensive overview of the current situation. Yeah, I think the government would want to invest on both parts of the project.
And a good incentive for us wanting to publicly share the data visualization is that we do have partner organizations such as the World Bank, and we could pitch to other humanitarian groups that could help fund this effort, because creating a standard map has been such a difficult obstacle because of the lack of streamlined data from one group that can be validated. So because we can offer that, we feel that we make a good case for acquiring additional funding from groups such as the World Bank.
I have a slightly different kind of question. How limited is the ecological niche of oil palm? So my understanding is that oil palm is a pretty flexible crop, relatively speaking, And so how much, because it sounds like you're pretty much sticking to biophysical characteristics and not, you know, other social kind of things such as land, you know, current land titling status or something like that as a predictor. And if you've thought about that a little bit, then, you know, how are you going to bring some of that in terms of what you're doing?
So to return to the data sets we have available, our information spans beyond the biophysical characteristics, and we also have information such as the farmers' IDs, their profile, cost output, and in relation to like how much land they have access to and the profits that they have. So I think that the data we output could be depending on what subsets we want to focus on, and then potentially do that statistical analysis we mentioned on seeing if the relationship between certain variables may point toward more likeliness for that area making for a good plantation. Obviously, in the initial stages, we would, of course, need to do more investigation to see what criteria validates what makes up a good plantation, and how can we teach AI to help identify other pieces of land that fulfill that criteria. But we have the data available and the blockchain technology needed to expand that data collection to definitely investigate that further.
I think that is the conclusion of our time for questioning, but thank you all. And
Thank
so
you.
the team can leave the call, and the judges have 5 minutes to deliberate.
Thanks so much, everyone.
Thank you.
Thank you.
Bye.